Good to go? Okay. We're good to go. We're going to start the afternoon session now. So this is the second annual year of the Cool K-PAC Competition. And so what we ask customers to do is share with us, if they can, minus any intellectual property that they may have buried inside of a K-PAC, some cool things that they've been working on and the business value that it's delivering to their organization. So last year's winner, we had 3 final entries, one from ZF, it had to do with selection criteria, Mr. Tom Valvano and his team there. We also had an entry from General Motors, looking at some trade-off curves, as well as Navistar, also looking at some trade-off curves. Navistar walked away with the trophy last year. And so this year, we have 3 final entries. We have one from BorgWarner, one from GM, and one from MIT Lincoln Labs. And so what we're going to do is go through each one of those K-PACs individually and then poll the audience to help select a winner. So first on the docket is BorgWarner, Mr. Matt Barron, and what he's going to do is explain to you the Cool K-PAC that he has entered into the competition. Matt.
You want to just be through here? Yeah, that's fine. Okay. Thanks, Jeff. Good afternoon, everyone. We're all full. It was a great lunch, so thank you guys for putting that on. That was very good. So again, my name's Matt Barron. I'm a global program manager with BorgWarner, and I think we have a pretty unique, cool K-PAC to share with you today. So to give you a little background on what our project was, we started in March, a seed project with the ROS team, and we wanted to look at how we can focus on our program management organization. So what you see here up on the slide is our program dashboard, and our goal was that we were, as Greg mentioned, a lot of organizations have to pull information from different functions. We waste a lot of time doing that. We did a poll within our organization, and our program managers were spending about 60% of their time updating metrics, doing manual reporting, chasing data. That's only leaving 40% of their time to focus on the customer, the program, launching it, and the suppliers. So we said our goal is to get that down to 38%. So from 60% of their time, we want them to use 38% of their time manually entering these reports and entering data. And that leaves a lot more time to focus on customer launch, flawless launches, focusing on getting suppliers ready for launch, and making sure that the program is a success. So how are we going to do that? We got with the ROS team, we put together what our vision was and our scope, and we came out with this program dashboard. So in a typical day, as a program manager, I would log into ROS, and I would have this program dashboard that you guys see on the screen here. And this is for each program manager, they would have one dashboard. So throughout the globe, there's a lot of different regions that we have. As you saw on Andrea's slides, we have plants in China, in Japan, in Italy, in Brazil, in the US. And so how can we make all these talk to each other and also have a good global read across so that as a global program manager or our management can go in and see what's the health of the program, are we on time, and are we going to have a successful launch? So from this dashboard, this would be one program, and if we go to the next. So what we tried to do here was roll our whole launch management process, all 7 of our gates, into this one tool. The first thing that we're going to go through is the flags. So from a status tab, when they create this program, the program manager can go in and plan out what the program timing should look like. So each flag is a key deliverable or a gate in that program. We can see if it's on time. If it's green, the gate review happened on time. If it's yellow, it was late. We missed that key deliverable. If it's red, the gate review hasn't happened and it's late. So visually, we can go in and see, is the program on track? And then we can also have reporting functions that track, and we can go back and look at our metrics and say, why are we missing key dates, and what can we do to improve that? So lessons learned. So that's from a gate timing. For each one of these gates, there's an assessment. So this is a method K-PAC that we put together, and then in each side of the gates is an assessment which has more K-PACs, which is all our deliverables support that gate. So from a high level, I can scroll over and see in gate 1, we have 34 different K-PACs in that assessment that need to be completed. Right now, we're 67% green. We have some yellow, we have some not evaluated, and some red. So quickly, we can go in and see that gate is yellow. That means we're missing some evidence, or we're at risk. There's a risk associated with that gate and with the program at that point. The next thing would be our EOT, so our executive oversight team. So each quarter we have a roll-up to our management to understand where are the programs at and are we going to be on track for launching with that customer. This allows us to do an assessment in each quarter, and we can track that history and say, is the program red? What functions? You can see that we have product engineering, quality, manufacturing. Each function is called out, and then we can call out what is the status and what are the next steps to get that program back on track. The other important thing here is we were using Excel to track our launch metrics. We were using SharePoint. People would check the file out. It would get corrupted. We'd have to go back, find out what happened. Either communication, someone was trying to check it out while someone had it. We wanted to get rid of that. It caused a lot of issues and a lot of data chasing. So launch metrics will be in each program. We can track our key performance objectives for that year and make sure that the program is performing good, and also do a global roll-up and a report out so that we don't have to manually do these reports in Excel anymore. We can just have ROS run the report every month, and we can publish that to the team. The other key things are lessons learned. So we realize that in our process, we do a good job of reporting out the status and tracking issues, but we don't do a good job of closing the loop and bringing lessons learned back in to make the process better. So in each dashboard, we want the program manager to go in and say, I learned this lesson at this point, it applies to this product line, and we're gonna make sure that gets incorporated into a gate. So we'll have a PMO officer, a program manager officer, who will look through all the lessons learned and incorporate them into the gates to ensure that each one is being checked off moving forward. And then also action items. The team can track who has what due when, and it'll send out notifications and reminders for the team. So that's the program dashboard at the high level for each program. If you go into a gate and you look at our assessment, we can sort it by function, so by customer, by product engineering, manufacturing engineering. We can sort it by champion so that we can see who has what to do. It gives the program manager, so when they go into gate 1, they get this plan and they can assign who is responsible for completing that action item and the due date. And it's only the deliverables that apply to that gate so that they don't have to filter through and understand, well, does this one apply to gate 2? Does this one apply to gate 3? It allows them to assign a champion, a due date, and it will send reminders. And then the other thing that we thought was important was evidence. So right now we're using SharePoint or a share folder or someone's computer to store evidence, and it's not accessible to everybody in the organization. So if we want to go in and say, let me see your DFEMA, let me see your DVPNR, let me see your tooling PO, all the evidence is stored right in ROS, so that if we have someone change programs, a new program manager come on, all the evidence is there already, and they can continue to launch the program. And then once the gates finalize, we can lock it down, put the status as complete, and then we can't have people going in and changing statuses or colors. We know what the history was on that program and how we got there. So at a high level, that's our K-PAC that we're implementing right now. We're rolling it out. It's a lot of good feedback from our team globally, and hopefully it'll help us get to that 38% target that we had. So thank you.
Thank you, Matt. And our next presenter is Mr. Daryl Yarbrough from General Motors. He is going to explain his Cool K-PAC entry into the competition here.
Okay, so with our Cool K-PAC, we went from the perspective looking at holes, and this is just a simple demonstration. When you have a hole, it serves a purpose. What's its reason for existing? And so there's, in this case, a bolt that's going through the hole, and it's going to control the dimensions based on which bolt you select, the dimensions of the key slot. And so we have a type ABC, type XYZ, type 1, and type 2. And those determine what the parameters of this key slot is going to be. And I can come in here, and I can select it from here and hit resolve, and it provides the parameters. Now, that's step one. But step two is I want to use that in a part file. I want it to drive a part file and have it give it to me automatically for free. So what we've done is we've created a template file. So basically what we have is a panel, a part representing a panel, and then a template file. And in that template file, we've used our version of a Oros linker where we're bringing the parameters into the part file. And then the user is able to make a selection in the UI and the template. It's going to execute those parameters that are brought in as expressions and then adjust the size of the key slot as well as swap which component is being used for background. And so here's the component here. We run in, we go in, and since it's a template, you can right mouse click, edit reusable component. It gives you this interface. And as we change the item that we're selecting, it's adjusting not only the size of the key slot, but it's also adjusting and swapping out the component that's being used. We also have a help button in there. If you select the help button, it actually brings up the book view of the K-PAC. And so now if I bring this template into a panel and position it, I can select the desired part, link in the tool solid, subtract it, and it automatically adds that component in the correct location. Everything's the correct size, and I know I'm complying to best practices. Any questions? It looks a lot cooler when it's live. No questions? Okay. Well, that's it.
Thank you, Daryl. And our final entry for this year is from MIT Lincoln Labs. Mr. Jim Carter is going to walk you through his Cool K-PAC.
Josh promised me the bike was going to work. Are we sure? Oh, we are. It is. Good. Okay. I'm going to preface this by two things. One is Lincoln Lab right now, we are just starting this process. What you're about to see is one of maybe 10 K-PACs that we actually have built. And the other preface that I will make here is that one of the things that we're hoping to do with this is how this is actually going to tie into other things as we move forward. So right now, one of the things that's kind of a pain point for us is being able to apply torque values, particularly for small screws, consistently and correctly over the course of any of the operations that we're doing. And small screws become a real problem because even if you're calculating what you should be doing for torque, it has a lot to do with what you're screwing into and how you've lubricated the bolt. All of those numbers get developed experimentally, and so what we want to be able to do is keep the best and most current numbers that have been done experimentally someplace for people to use and then be able to incorporate it. So the way that this K-PAC is set up, it's a method set so that you will select the bolt size. So the designer in this case, and Sean's going to be my designer, he's going to go and he's going to select the bolt size. And it all comes out from a predetermined list, so. What did we pick? Number 4?
Number
All right,
4.
Number 4. Then he hits resolve, and so what that's going to do is it's going to populate that field based on the information associated with a number 4 bolt. Then he's going to go forward. Now we have a set of rules that we haven't actually put into this K-PAC yet that will let you determine whether you can use a default value or whether you need to do an actual calculation. In this case, we're going to assume that we cannot use the default value, and we're going to go to calculation. So the next thing, actually, after he resolves that, the next thing he's going to do is he's going to select what the screw material is. And there are certain preset materials that we can use. When you pick alloy. Okay. We'll resolve that one. Okay. Then he's going to select what we're calling the nut material. Now this may be an actual nut, or it actually may be a threaded hole within a plate of some material, so that there are a number of materials that we can choose from here. So if we choose the nut, choose the material, let's just, what do we got? Let's pick aluminum. There you go. Resolve that. And one of the things that it's adding here before we move on is that there are actually going to be material limits that are associated with any of the materials that we're using. So in this case, it's provided us with a material limit or shear limit for aluminum as we've got it defined. So you can resolve and close that now. Then you're going to pick the lubrication type. Okay, this is the thing that's going to determine what the nut factor is associated with this particular torque calculation. Now, when we start to talk about the lubrication piece, and this is one of the reasons why we're interested in having this be a piece that we can put into a knowledge pack like this and keep it updated, is that right now we are in the process of redefining what any of our approved lubrication pieces is. So we have one in here now that we are phasing out, and what we want to do is make sure that that is no longer going to be a choice for people to use once we've got that completely phased out. I didn't realize I was going to have to do stand-up today. So, how do you fill dead time when you're standing on stage, right? I could tell a joke. That's a very dangerous thing to ask me to do, though. So, tell us a knock-knock joke. My kids.
It should work. Thanks.
This right now, there's a K-PAC associated with each step. And each, there's a value table associated with each step, obviously, that's going to allow us to go through this. So we're going to pick dry. Actually, why don't we go back and pick IPA? You can lubricate with pretty much anything. I am going to lubricate with IPA. Okay, and then we're going to go down. In this case, what we're going to do is we are going to choose to pick either, are we going to define a torque, or we're going to determine a preload. So what we'll do is we'll pick force, which is going to be our preload. Okay, and then when we resolve this, it's going to ask us to input whatever the force is that we want to calculate. So we'll enter in, whatever our clamping force wants to be. And you can actually type something in. Let's type in 50. If it comes up yellow, that means that we are below the limit for what we're allowed to be for either the bolt or for the material, which means that we're safe, but we're not necessarily optimal. Green would fall into an optimal range, and if we are in red, as a marker, that means that we are outside of what's considered to be an acceptable limit. The thing that we are going to be doing with this, and it's the part that's going to hopefully make this cooler than what it looks like right now, is that this is actually going to get tied back into our CAD system, so that when you actually pull up an assembly, what it will do is go in and find the screws by size, will follow through everything except for the lubrication piece and most likely what your force needs to be, and then it will spit this value out as correct or not correct. You can make any kind of correction to get it into the green level that you need to be, and then the output value will be able to be written out to a drawing spec for the assembly drawing so that it's on the drawing for people to use. So, any questions? All right, thank you very much.
Thank you. Sorry for conflict technical.
Okay, so now we're going to go to polling. So on the mobile app, you'll have an opportunity to vote for this year's winner of the Cool K-PAC Competition. It's neck and neck. Okay. Do we have everyone, all the votes are tallied? Okay. Well, it looks like this year's winner is Mr. Matt Barron from BorgWarner. Come on up, Matt.